Section 12.2, frequency distributions and statistical graphs. So when we collect data, we have several pieces of data. So a piece of data is just a single response to an experiment, and often there's thousands of pieces of data, and so statisticians will organize them in what's called a frequency distribution. A frequency distribution is just a listing of observed values and how often that value came up during the experiment. So for example, the number of children per family is recorded for 64 families surveyed. Construct a frequency distribution of the following data. I have the data on the next slide. So if you were a statistician, this is, it's a great listing of your data, but it's not as organized as it could be. And so what we're going to do is put this in a frequency distribution just so that it's a little more clear what we're actually looking at and so that you can see the flow of the data. So I'm just going to scoot this over a little bit. I like to make my frequency distributions look like a T-table. Oh. There we go. And on the left-hand side of my T-table, I talk about the values. In this case, we're talking about numbers, a number of children. And then on the right-hand side of my table, I put the frequency. So when I did my experiment, how many times did this occur? So the first number that pops up on my observations is the number 0. And then I'm going to go through and I'm going to count how many zeros I see on the table. And I see 8 zeros. So I'll put the frequency on the right. Then I see the number 1. And I see the number 1, I see the number 1 11 times. Then we have the observation 2. Lots of those. And observation 2 occurred 18 times. And then we have observation 3, which happened 11 times. Observation 4, I see 6 times. Observation 5, 4 times. Observation 6 happened twice. 7 happened once. 8 happened twice. And 9 happened once. Now, you can check to make sure you counted correctly by adding the frequencies together. Those should total to be 64, which is how many families we had in our survey. So this table right here is your frequency diagram. Now, sometimes instead of just listing the 0, 1, 2, 3 off to the side, we like to use classes, which are going to be ranges of values. So the classes all need to be of the same width. The classes should not overlap. A piece of data should not belong to more than one class at a time. And it's recommended that you have between 5 and 12 classes. If not, your data can be skewed and you don't get the full response that you're looking for. So here's an example. So if you notice, I'm going between 0 and 4, 5 and 9, 10 and 14, 15 and 19. So notice that the upper limit of the first class is related to the lower limit of the second class. The items that are on the left-hand side are called the lower class limits. That just means it's the bottom boundary. The items on the right-hand side are called the upper class limits or the upper boundary. The midpoint is going to be found by taking the lower limit plus the upper limit and dividing by 2. So for example, if I wanted to know the midpoint of this first class, I would take 0 plus 4 divided by 2. So the midpoint would be 2. The width can also be found by taking the lower limit of group 2 minus the lower limit of group 1. So let's check out this situation and see what's going on. The following set of data represents the family income in thousands of dollars rounded to the nearest hundred of 15 randomly selected families. Construct a frequency distribution with a first class of 31.5 to 37.6. Okay, so we've got the data on the other page, but first let's set up our frequency distribution. So we're going to make our table, and we have to first pick out how we're going to space this table. So if we look, first thing we want to do is we want to arrange our data from smallest to largest, and you're doing that so that you can identify what your lowest value is and what your highest value is. Then we're going to develop our frequency diagram. So I like to do it as a T-table. So I put the values on the left, and I put the frequency on the right. I'm just going to put F for frequency. And they told me that the first value, or the first class, should be 31.5 to 37.6. Now, you see how they're going to one decimal place? That's important to pay attention to, because when you go to your next class, you want to go up by one decimal place. So we'll start at 37.7. Now here's where a lot of people get stuck, is they don't know how high up to go. So what you need to do is you need to figure out what your class width is. So take the lower limit from the class you just found and deduct the lower limit from your first class. And when you subtract those, you're going to get 6.2. So what that means is you're going to keep counting up by 6.2. So we're going to take 31.5 and we're going to add 6.2 to it, and that's going to give us our new lower limit of 37.7. Add 6.2 again, and we're going to get 43.9. Add 6.2 again, and you'll get 50.1. Add 6.2 again, and you'll get 56.3. Add 6.2 again, and you'll get 62.5. Then we're going to do the same thing with the upper limit. Our upper limit was 37.6. I'm going to add 6.2 to it, and I'll have 43.8. Add it again, and I'll have 50. Add it again, 56.2, and again, 62.4, and again 68.6. Now you want to go over to your data and you want to look. So we're looking for all the numbers between 31.5 and 37.6. I see two numbers. We're looking at all the numbers between 37.7 and 43.8. Three numbers. Between 43.9 and 50. Five numbers. Between 50.1 and 56.2. Three numbers. Between 56.3 and 62.4. One. And between 62.5 and 68.6. One. And you have organized your frequency diagram. Sometimes we like to take those frequency diagrams and turn them into what's called a histogram. So a histogram is a graph, and it's going to have the observed values on the horizontal scale, and it'll have the frequencies on the vertical scale. These graphs are going to be easy to interpret visually, and you see them a lot. In general, they tend to look like bar graphs that are touching each other. A bar is going to be constructed above each observed value or class, indicating the frequency of that value. The horizontal scale does not need to start at 0, and The way you count the horizontal scale and the way you count the vertical scale do not have to be the same. The vertical scale must start at 0, and sometimes if you have a really, really large frequency, you may have to do a break on your graph with the little squiggle so that you can get to the actual data points. So let's look at a situation where we're going to turn our frequency diagram that we just created into a histogram. So remember, our frequency diagram from the first example that we had is reviewed here. Now let's turn that into a histogram. So a histogram is just a bar graph. So I'm going to scoot this off to the side. And I'm going to put my observed values down here on my horizontal axis. So my observed values are 0 through 9. Then I'm going to put the frequency on the vertical axis. The smallest frequency I have is 1. The highest frequency I have is 18. Now I do have to start at 0. I probably don't want to count by ones if I'm trying to get up to 18. So I'm going to count by threes. 3, 6, 9, 12, 15. 18. And then what I'm going to do is above each of my observed values, I am going to plot the frequency. So the number of families with 0 children was 8. And I'm going to make a bar. The number of families with 1 children was 11. 2 children was 18. 3 children was 11. 4 children was 6. 5 children was 4. 6 children was 2. 7 was 1. 8 was 2. And 9 was 1. And so now you have your histogram. Now every once in a while they're going to ask you which one is the modal class. The modal class is just the one that happened the most often. So our modal class would be modal class of 2 children. Another way to represent data is with what's called a frequency polygon. Frequency polygons are just line graphs, and the scale is going to be the exact same as the histogram. So the horizontal scale will be where your observed values are, and the vertical scale is going to be where the frequency goes. To graph these, you're going to place a dot at the corresponding frequency above each of the observed values. Then you're going to play a game of connect the dots with a straight line segment. When constructing the frequency polygon, always put in 2 additional class marks, one at the low end and one at the upper end. Since the frequency of these is going to be 0, the ends of the polygon will always be on the horizontal axis or the x-axis. So we're going to do the same example we just did. We're going to use example 1 data, and we're going to construct a frequency polygon. So I have the data here for you. I'm going to make it smaller so we have room to draw our frequency polygon. I'm going to put the observed values down on the x-axis again, 0 through 9. And then the directions said to do 1 more to the left and 1 more to the right. And then I am going to do my vertical scale, which needs to go from 0 to 18, 3, 6, 9, 12, 15, 18. Now, in this situation, you are going to put dots on your graph. So for 0 children, there was 8 families. 1 child, there was 11 families. 2 children was 18 families. 3 children was 11 families. 4 children was 6. 5 children was 2. 6 children was, 5 children was 4. 6 children is 2. 7 children is 1. 8 is 2. And 9 is 1. So we're going to do connect the dots between all those lines. And then to make it a polygon, we need to bring it down to that extra spot we made on the x-axis. And now you have a frequency polygon. So it's very much like a histogram, it just looks a little bit different. Okay, the last type of frequency distribution that we can see is the stem and leaf display. This is a tool that will organize and group the data, and it's nice because it allows us to see the actual values that make up the data. To construct a stem and leaf display, each value is represented with 2 different groups of digits. The left group of digits is called the stem, and the remaining group of digits on the right is called the leaf. There is no rule for the number of digits to be included in the stem. Usually the units digit is the leaf and the remaining digits are the stem. So the table below indicates the ages of a sample of 20 guests who stayed at the Captain Fairfield Inn bed and breakfast. So construct a stem and leaf display for this set of data. Okay, so I'm going to scoot it off to the side so we have some room. And this is going to look like a bar right down the middle. Okay, first thing I want to do is look for everything that starts with a 2. I've got a 29 and a 28. So I'll put the stem as the 2, and then the leaves are 8 and 9, like that. And I've used those data. Then I want everything that starts with a 3. I've got a 31. Oh, did you guys notice I left out that 27? So let me fix that. So I've got a 27, a 28, and a 29. So I think I hit all the 20s. Now we're going to move on to the 30s. So I've got a 31, 39, and 32. So I'll put the 3 for the 30s, and then I'll put my 1, 2, 9, like that. Then I'm looking for 40s. I've got a 47, 44, 45, 44, and 43. So I'll put my 4s down, and then I'll put 3, 4, 4, 5, 7. Then I'm going to move up to the 5s. I've got a 59, a 50, a 58, and a 56. So I'll put my 5 for the 50s, and then I'll put 0, 6, 8, 9. Then we need our 60s. So I've got 60, 62, and 68. So I'll do a 0, 2, and an 8. And then last, I have my 70s. So I'll do a 72 and a 71. And you just made a stem and leaf display. Now, I personally like to have my leaves go in order. Some people don't. Some people just slap them on there as they go. That's totally up to you, but I think it makes more sense to have them in order. Okay, last but not least is circle graphs. Circle graphs are also known as pie charts, and they're often used to compare parts of one or more components to the whole. So for example, 800 people who attended a Ringling Brother and Barnum and Bailey circus were asked to indicate their favorite performance. The circle graph shows the percentage of respondents that answered tigers, elephants, acrobats, jugglers, and other. Determine the number of respondents for each category. So let me pull the circle graph up for you so that you can see it. And notice that when you add the percentages together, they should add up to be 100%. And in this survey, they said they talked with 800 people. So to figure out our percentages, or our number of people for each characteristic, we just need to take our percent and turn it into a decimal, and then multiply it by 800, and that'll tell us how many people liked the tigers, the elephants, the acrobats, the jugglers, and other. So remember, when you turn your percent into a decimal, you're just going to divide that number by 100, or you can just shift your decimal place 2 spots to the left, whatever makes more sense to you. I just do shifting, but sometimes people struggle with that. Okay, so if you do your mathematics here, or your arithmetic, there should be 304 people that like tigers, and 208 elephant lovers, 136 acrobats, 112 jugglers, and 40 people who voted for other.